Hi students, how are you all? Today we are going to learn how the alkali metals are reacting with other compounds, right? In generally, the reactivity of alkali metals are very high, right? So because of high reactivity, they will easily react with other compounds. What is the reason they are having high reactivity? If you go down the group, usually we have vertical columns are called groups. So we are learning about first group. So from top to bottom. So go down the group. The reactivity will increase from lithium to cesium. Why the reactivity increases? Because the down the group ionization energy, ionization potential will decrease. Because of decrease of ionization energy, reactivity will increase from top to bottom. Listen, the alkali metals are readily react with more electronegative elements. What do you mean more electronegative elements? Which having the tendency to accept the electron. They are called electronegative elements like oxygen and halogens. More electronegative elements, oxygen and halogens are readily reacting with alkali metals. They are producing generally as ionic compounds, right? So chemical properties of alkali metals we are going to see one by one. The first reaction, as usual, reacting with air or oxygen. That's the first reaction. Reaction with air, or we can say oxygen, right? So the alkali metals, they are vigorously reacting with air, right? So here you can remember one general question. What is that? Why sodium metal as well as potassium metal kept in the kerosene liquid? Why? If you keep it in the outside or in the bottles, it will react vigorously with air, it will catch fire. It may happens accident. Because of that, we are keeping the sodium and potassium in the kerosene liquid. Yes. So that much reactivity, right? So the alkali metals are highly vigorously reacting with air or oxygen. They are producing alkali metals with oxygen, air, producing oxides, metal oxides. Usually they are giving different types of oxides, right? So the first one, lithium. Lithium gives normal monoxide. But sodium can produce two type of oxide, monoxide as well as peroxide. Do you know all other elements? What are they? Lithium, sodium, potassium, rubidium, cesium. They can form monoxide, peroxide along with superoxide. So how will you define or how will you differentiate monoxide, peroxide, superoxide? The oxidation state of oxygen -2, that is called monoxide or normal oxides. Peroxide, it may have -1, superoxide -1/2, right? Or sometimes may have +1/2, right? So this is different. Now we will see the general equation. How the lithium is reacting with oxygen. It will give lithium oxide. Balance this equation. So this is lithium monoxide. It will form only simple oxides. But sodium can form sodium peroxide. The oxidation state of oxygen is -1. Other metals, they didn't give any particular metals. We will substitute metal with oxygen. It may produce superoxide. How? MO2. For example, we will substitute M. What are the things may replace the M? Remaining elements in this group: potassium, rubidium, cesium. For example, you substitute cesium, it will give cesium oxide. So superoxide, peroxide and monoxide or normal oxide. And then reaction with hydrogen, the second chemical property, how the alkali metals are reacting with hydrogen. See, they are also, all the elements reacting with the hydrogen, they are producing ionic hydrides. What product will get? Hydrides in ionic condition. We will get ionic hydrides. Okay. Here the condition is important. Lithium only reacting at 1023 Kelvin, 1023 Kelvin. But all other elements in this group, other elements like potassium, sodium, rubidium, cesium, even with 673 Kelvin, it will react and giving ionic hydrides, right? What's the reason? As usual, the reactivity increases from top to bottom. If you go down, the reactivity will increase. Because of that, with low temperature, it will react. Then, how the hydrides are formed? Metals with hydrogen, it will form metal hydrides. Listen, always the hydrogen you have to take it as a molecule. So, right, how it will ionize? M plus H minus. Because of that, we are telling ionic hydrides. Shall we substitute any one compound? Yes, substitute sodium. How will you get? 2NaH2, H, not H2. Like we can get the ionic hydrides. See, here one more additional point we have to mention. They are not more stable, they are less stable if you go down, because reactivity is high. Because of that reactivity, if you go from top to bottom, that stability of hydride is decreases. Very important. Stability from top to bottom decreases. And then we can say they are acting as a reducing agent. Why sir they are acting as a reducing agent? Because they are undergone the oxidizing nature. See, not the metals, the metal hydrides acting as a reducing agent, because it can readily give the hydrogen, right? So it will give hydrogen, it will help for reduction of other compound. That's why we can say the metal hydrides, they are having reducing nature. So we can call it reducing agent, right? Then reaction with halogen. How the alkali metals are reacting with halogens. As usual, halogen, electronegative element. So easily it will react with halogen. How the metals are reacting? It will give ionic halides. It is also what will happen? Top to bottom reactivity will increase. From lithium to cesium, it will increase the formation of ionic halide. See here how the general reaction may take place. 2M instead of metals, X2, 2MX. So what are the things you can substitute for metals? For metals you can substitute lithium, sodium, potassium, rubidium and then cesium. Francium usually will not because radioactive. Here halogen. What is halogen? Do you know? Fluorine, chlorine, bromine and iodine. Here one important thing we have to learn. First we will write one example, right? Which metal we can take it? Okay. Sodium. If you take 2 sodium, with which one you want? Shall you take Br? Br2. So 2 NaBr, sodium bromide will form. Okay. The same way, you take the first element in the group and the last element in the halogen. Lithium with I2. It will produce lithium iodide, right? See, among all the halogen, the lithium iodide having more ionic character. Why in this sense? They are having more polarizing ability. Why they are having more polarizing ability? See, here you have to remember one rule. You may learn in the 12th also. Fajan's rule. What is that? Fajan's rule. Whenever a ionic compound is formed with smaller cation, larger anion, it will have more polarizing power or it will easily ionize into ions like lithium plus iodine minus, like it will get the polarizability, high polar in nature. Because of what's the reason? Small cation, large anion. Okay, this is very important. Because of this reason, all other halogens are ionic halide, but lithium iodide alone, not I2, sorry. Lithium iodide having covalent character. Very important, my dear students. All other ionic halides are ionic in nature, or other metal halides are ionic nature, but lithium iodide combination having covalent character because of this high polarizing ability. This is very important because they may ask in reasonable questions. Okay, right. Then how they react with ammonia solution? Alkali metals, how they are reacting with ammonia? What's the molecular formula for ammonia? NH3. So metal halides react with ammonia, very important one mark, giving deep blue color. What happening? Alkali metals, very important. Alkali metals reacting with ammonia, which giving deep blue color. Why this deep blue color is produced? Because of which forming ammoniated compounds. What are the ammoniated compounds they will produce? Right? See here one more additional point. They are given very important. The conductivity, right? If you dissolve with ammonia, alkali metals, if you dissolve with ammonia, we are going to talk about their conductivity. Usually the pure metals will have more conductivity, like mercury having a specific conductivity 10 power 4. What's the unit? Ohm inverse. If you see that sodium liquid having a conductivity 0.5 into 10 power 4 ohm inverse. See, pure metal having only 10 power 4, the same, nearly same, 0.5 will not change many changes, not a big change, but you can compare 10 power 4, 10 power 4, because of that they are having more conductivity, high specific conductivity. See, once the metal giving the more conductivity means we can say there is a free electrons. What do you mean free electron? How the free electron is formed in alkali metals? Listen carefully. When the metals are treated with ammonia solution. We need two compartments. That's why we are writing X plus Y NH3. So X amount of NH3 is added with this metal X plus some amount of NH3 is going along with the electrons. Here M plus will form. Okay, usually you can write like this as a coordinated bond. Electron also going with some ammonia. Okay, so here minus means you should not read, put, right? Or common minus we can carry. See, because of this reason, right, ammonia reacting with metal, alkali metals, they are producing ammoniated metals as well as ammoniated electrons. Because of this ammoniated electron, they will have the high conductivity, right? It is equal to pure metals. Listen, see here the blue color. Why sir? Conductivity increased because of ammoniated electron. Okay, why they are producing this blue color, deep blue color? See, when it form as an electron in the solution, it will absorb some heat, some energy from the light. This free electron is absorbing energy from light. Because of that, it will give the complementary color blue, right? So that the electron absorbing light energy, because of that absorption, it producing that blue color. This is also important 1 mark. Sometimes they may ask in the 2 marks also. Very important, right? See here, before absorbing, right, what will happen? Which having paramagnetic character. What do you mean paramagnetic character? If you have single electron or electrons are separately, we can say paramagnetic. But even though if you keep the solution for some times, slowly it will give the hydrogen. How the hydrogen reaction will produce? How the ammoniated metals and the electron giving? Electron is there, metal is there with ammonia. How this solution will give hydrogen? This metal will combine with this NH2. It will form metal amides. Then it will produce that minor charge H plus neutral. So we will get hydrogen gas. It will happen for keeping long time, right? So because of this reaction, now we don't have the free electron. When we have the free electron, we may have the blue color, but we don't have in the product, one of the product as an electron. So the blue color will disappear and also it will form bronze color. It will produce bronze color because of that slow reaction. Now, when they are blue color, they are existing as a paramagnetic. If it is converted into bronze color, it becoming diamagnetic character. Why it becoming diamagnetic character? They combined as a pair. Okay, single electron present means that is paramagnetic character. All the electrons are present as a pair. We can say diamagnetic character, right? Then how the alkali metals are reacting with water? Usually alkali metals reacting with water will give hydroxide. Basic hydroxides will form with water. They are producing hydroxides. Okay, we'll see one example. Lithium reacting with water. What will happen? Here water will divided into H plus OH minus. So 2 lithium with 2 OH, it will produce lithium hydroxide. What are the remaining? 2 hydrogen. So H2 gas will produce. So in this reaction hydrogen gas is produced. Right? See, lithium alone directly reacting with water and